This is one more class of my lecture flow. Okay, at least you just have a look on how the flow of the lecture or how the content is being elaborated for the class discussions. Okay, so this I meant for concept map. Okay, the initial process or lecture 1 starts about talks about physical, chemical, and biological characteristics of water. Okay, that's what we discussed in the last class also. Okay, so physical characteristics, which includes turbidity and color, taste, temperature, and odor and solids. So these physical parameters. Just take a water from a source and test these parameters, and either by physical sense or by seeing through or by observing the color or by understanding the temperature profile or by smell, you could able to say the quality of water. Okay, turbidity is mainly because of colloidal solids which is present in the water. Say example, if you certify the water, as example, satisfies with his chemical and biological characteristics, even some parameters of physical, but if contains with a lot of turbid or colloidal matter, then probably you won't take. Okay, that is about turbidity. And color, say example, maybe with the natural colors like yellow, brown, tint, black, pink or something. So if it is any color in the water, then normally people may not have a feel like to take. Okay, color by physical observation. Okay, that is about perception registered by your retina of your eyes. Based on that, you may also say that water quality is good or bad. And by tasting something, okay, just taste the water, and if you feel like any taste other than what you normally expect, okay, that you can classify as water is something has been contaminated or is been added with some sort of salt or water. Okay, and by physical touch, you could also feel like any temperature. Normally, the water it is in the atmospheric temperature. Normally, it is or sometimes is below the atmospheric temperature, and if it is more than temperature range, more than the atmospheric temperature range, then you could also feel like some heated water or the industrial effluents also is being introduced in the water system. Okay, so thereby you can also claim to be the water is not good for drinking or something. Odor, say example, if you smell it and if you may feel like earthy odor or fishy odor, then you can also say that water is not good. Okay, and by physical measurements of solids, and you can also have a look on if the solids is more than a particular value, then you can say that this water is not good and I have to remove the solids well in advance before going for a consumption. Okay, so this we will be discussing in detail. What are the physical characteristics? Okay, as of now, just understand the logics of what is physical characteristics. Okay, and if you take it to the laboratory, these are the predominant chemical characteristics of concern in water. Okay, so you check your calcium, magnesium, sodium, potassium, carbonate and bicarbonates, sulfates, chloride, and other ions. Especially, we may consider almost 3 or 4 contaminants like nitrogen as well as phosphorus, iron, and manganese. Okay, some areas where you have to concentrate on fluoride also. Okay, so this I have picked up some essential parameters you should know, which will cause chemical quality alterations in the water. Okay, calcium and magnesium would are familiar, and this is with the soil. And if it is anything on sodium into the soil, there could be a ion exchange reactions. Calcium and magnesium silication in the soil. And if it is anything on the sodium addition, and calcium will be replaced by sodium, and calcium and magnesium will be available in the water. Okay, and if it is more or less, it will also create a lot of problems. That also would have come across. Calcium and magnesium, it will create scale formations in your pipe carrying, say example, pipelines or your utensils or something. Okay, so that you have a value where we will discuss like what are the essential sources and either natural or anthropogenic sources, and what is the limitations, and if it is in excess, and what will have a problem on your pipe networks or drinking water supply lines. So we'll be discussing in detail calcium, magnesium, sodium, potassium. These are the predominant chemical ions or ions present in the water. And bicarbonate and carbonate, that you would have familiar with buffering capacity of the water. Normally it has been estimated with the carbonate and bicarbonate system, and sulfates predominantly, and chloride plus other ions. Imagine now a situation where the wastewater is being introduced or treated or used water is being introduced into a river. A river have a capacity to clear by its own during the process called self-purification. And after the disposal point, you may tap water for your consumption. That's what normally they do it. And if it is anything on the organic contaminant addition into the water system, And water or drinking water, whatever you tap, may also contain nitrogen as well as phosphorus. That is number one. That we'll be discussing. Some areas, the underground rock system or soil systems may also have iron and fluoride related rocks. So thereby there could be a possibilities of iron contamination and fluoride contamination in the water systems as well. That we'll be discussing in detail. And minor trace on organic inorganic constituencies. Okay, so whatever we discuss in this class is mainly very lighter fractions of chemical characteristics. Now people have gone into a higher level, and they may also target now priority pollutants that you would have come across. And second one is about personal care and pharmaceutical products. People have traced out different components of personal care and pharmaceutical products components also in the water, drinking water system. Okay, and endocrine disturbing chemicals in the water, pesticides in the water. So these are some sort of advanced level of targeting the chemical contaminants. Anyway, for the UG point of view, BTech level, then we'll be discussing in detail of these chemical characteristics. Okay, yeah. Now, how to find out or how to say the water quality is good or bad without measuring these individual contaminants. So that we call it as quality indicators. Okay, if I test pH of the sample, if I test the alkalinity of the water, and if you measure the conductivity of the sample, if you could able to find out what is TDS of the sample, dissolved solids of the sample, and if you're able to measure the hardness, okay, and if you measure the corrosivity of the water, then you could able to say something about the water quality characteristics. So please remember, the characteristics is different, quality indicators are different. Okay, so if the pH, alkalinity, conductivity, total dissolved solids and hardness of the water is known, then we can say something about the quality of water. So that's what has been mentioned, water quality indicators. Okay, by measuring TDS, you would have familiar in your household levels also. If you have a RO, normally people may ask, what is your TDS of the sample? That's what, very simple. Or they may ask, what is your conductivity of the sample? Sometimes if you depend on groundwater, they may also ask, what is your hardness level in your locality or in your water, hardness, or whether it is hard water or soft water. So by measuring some quality parameters, you could able to say about the quality or chemical characteristics or quality of your water consumption. Okay, that's then we will be discussing in these parameters in detail. Okay, and water normally should be free from organic contaminants. That you make it very clear. And water, whatever we consume or whatever the potable water should be free from organic matter. Okay, so nowadays there could be possibilities of lot of naturally or man-made organic matter also into the water courses. That's something is important. Okay. So these are the naturally occurring organic matter. Typically, we may call it as NOM. Okay, naturally occurring organic matter. Okay, that is because of either it may present in the soil and because of microbial activities or because of anaerobic decomposition. Okay, there could be possibilities of humic compounds, proteins, tannin and lignin, grease and wax, aromatic oils, sugars and carbohydrates, metabolites, and man-made even. Plus, you may have so much amount of man-made organic matter also. So this we will be discussing little bit on organic constituencies in water. Okay, so please remember, typically speaking, water should be free from organic contaminants. Okay, yes. And if it is any organic contaminants in the water, how to measure? How to measure organic content in the water? So normally, you can have two different methods. One is you can estimate through biochemical oxygen demand. So this BOD would have come across in the UG first year chemistry. Okay, biochemical oxygen demand. Okay, you just estimate BOD of the sample, biochemical oxygen demand of the sample. It's very simple. Normally, these organic contents are getting degraded by the presence of microorganisms. These microorganisms take up this organic matter as a food, and during the degradation, it will also consume oxygen. So you just remember simply right now, how much amount of the oxygen is getting depleted or is used to degrade the organic matter by the presence of or by the utilization of microorganisms in the water. So that you can estimate in terms of biochemical oxygen demand. Please remember the word BOD, okay, biochemical oxygen demand. How to test this BOD of the sample in the water, okay, that in the laboratory, that we'll be discussing in detail, how to measure BOD of the sample. Okay, so BOD normally that you just take out the sample and you just incubate in an incubation bottle. Okay, that we call it as normally is a BOD bottle, and incubate at a 5 days duration at 20 degrees Celsius in the incubator. Okay, and before incubation, you measure the oxygen level or oxygen content or dissolved oxygen content in the sample. And after incubation, after 5 days, take out the sample, measure the dissolved oxygen, which is already present in the incubation bottle. Okay, initial DO you may know, and final DO after 5 days you may know, and initial minus final you may find out what is the consumption by the bacteria. That this is called oxygen demand. So how to estimate these parameters in the laboratory we'll be discussing in detail. Okay, that we may call it as BOD test. Okay, so whatever because this organic matter probably would have come across in UG or in the first year level. The organic matters is the comprises of biodegradable matter and non-biodegradable matter, or you can call it as simply carbonaceous matter and nitrogenous matter. Carbonaceous and also nitrogenous. So whatever you estimate in the laboratory, it is only on carbonaceous matter. Okay. So what normally happens in the aerobic environment, organic matter will feed on this carbonaceous matter, which will convert into carbon dioxide. Okay. Carbonaceous carbon into carbon dioxide by aerobic degradation. So some cases there could be a possibilities of nitrogenous components also, nitrogenous matter also in the along with organic matter. Organic matter contains carbonaceous matter and nitrogenous matter. Okay, and this 5 days duration of incubation may not be sufficient to take up this nitrogenous matter by the microorganisms. If you prolong beyond 5 days, there could be a possibilities of nitrogen degradation as well. That system is called as nitrification. You would have come across. Okay, so protein what you consume, and protein normally hydrolysis into ammonium or free ammonia, and ammonia into further into nitrate into nitrate. That process you can call it as nitrification. Okay, once you go beyond 5 days of incubation, you could able to also estimate the oxygen demand by the nitrogenous bacteria. Okay, so that we will be discussing a little bit on nitrification in the BOD test also. Okay, yeah. And the second one is COD. This is also actually a oxygen demand. But if you want to find out the organic strength of the water, then you have to wait for 5 days. That's what I told you. 5 days incubation at 20 degrees Celsius. But chemical oxide demand, what do? You use chemicals, strong oxidants, to oxidize the organic matter in the presence of some catalyst. Okay, so that by chemical method. So chemical oxide demand by chemical addition. You just oxidize the organic matter in the presence of a catalyst. Okay, in an exposed or elevated temperature. And if you go for a titration, you could be able to find out what is the oxygen demand. Okay, this you can finish it up within 1.5 hours to 2 hours. Okay, it's normally the advantage of doing with the COD experiment is like that. You use strong oxidants to oxidize the organic matter. Okay, so that we'll be discussing what is open reflux method and what is closed reflux method. Okay, yeah. Third segment, being familiar with physical and chemical characteristics of water, and we'll be discussing in detail with biological water quality characteristics. And predominant microorganisms in the water are bacteria, protozoa, and virus. Some cases is algae. Okay. So out of bacteria, protozoa, and algae, normally we will not consider virus in the water system. Virus, we will not consider anything for treatment or something, because virus doesn't have a metabolic activity. So please remember that is something is important. Virus we will not consider anything for any design purpose or something, because virus doesn't have any metabolic activity. Okay, so we'll be discussing on the essential characteristics of these bacteria or pathogens and disease causing organisms as well, and what are the different organisms which is responsible for different waterborne diseases. That also we'll be discussing in detail. Okay, yes, yeah. And to check the biological water quality of water, normally this is very, very difficult to target, whether it is bacteria or virus or helminth or algae. So what they do, they may go for a sanitary analysis of water by targeting indicator organisms. Please remember that's a word, indicator organisms. Okay, and if you target, or if any indicator organisms present in the water, then you can indirectly or directly say that water is contaminated with some biological matters, either bacteria, protozoa, or virus, whatever may be. Okay, yes. So indicator organisms, you have certain criteria. Indicator organisms, that these are not harmful, and this also may grow in a systems in any conditions. Okay, it will also will not multiply by its own because of these conditions. Then detection is very, very easy. That's what I told you. You just target the indicator organisms, thereby you can able to say the quality of water. Okay. So indicator organisms in the water concerns are coliforms. Okay. Coliforms. Then how to test the coliforms, that we'll be discussing on. If you give a sample to a lab, okay, and if you have anything on the water contamination, and normally they do these tests, presumptive test, confirmed test, and completed test, and after that they'll give a confirmation, okay, that your water it is contaminated with some suspections, either bacteria or virus. Okay, and if it is further, they may also elaborate what type of bacteria and what type of virus into the water system. Okay, so these are some elementary discussions on water quality characteristics. Is it okay? Is it fine? Yeah, Divya and Rashwant can react.
Yes, sir, fine.
Yeah. Okay. So this is lecture 1, and lecture 2. That's what we have discussed is about demand, type of demand of water, types of water demand, and design period. Also, I already mentioned, because water supply networks are designed for almost is 25 years projection. Okay. I cannot have, or I cannot augment the water supply networks very periodically. So they may project, if you want to design, say example, water supply networks for a new developments in Trichy, I may plan for what could be the population in 2000, say example 35. For that, I have to design the systems now. That's what design period. Most of the projects, it is about 25 years of time. Okay. So water demand, what we have discussed, like domestic water demand, industrial water demand, institutional water demand, demand for public uses, fire demand, and other water required to compensate losses in waste and also theft. Okay. This we will discuss in detail. What are the different water demands? Domestic water demands, I already mentioned to you, is about the Indian system. We may also supply 135 liters per capita per day, but in developed nations they may go beyond. Sometimes it's 220 liters per capita per day also. An industry, then you have a factor, institutional and also commercial, based on the input, based on your number of population, okay, number of students, number of prisoners, say example, number of patients in the hospital, and number of people, those who are visiting to the mall. So based on that, they will also create water demand. Okay, public users would have seen, say example like public parks and other things and all. Fire demand. Okay, if it is anything on the emergency fire accidents, you could also able to tap the water from the regular pipe networks. So we'll also calculate what is fire demand, and there could be a possibility of water losses by leaks, or there could be a water tapping through thefts. That also you would have seen. Okay, you may design a perfect design, but some areas there they'll also like take out water illegally, water theft. Okay, so this we'll be discussing in detail, and these are the factors affecting the per capita demand. That probably would have come across. If the city has more population, the demand will be high. Climatic condition, just compare colder climate and hotter climate. Hotter climate, they may go for excess consumption of water than the colder climates. And types of gentry and habits of people, and luxury and non-luxury people, or say example, people those are in the urban city, urban agglomerations, as well as in rural agglomerations, they may have a different habitual sensations. Okay, and industrial activity and commercial establishments, you may have a different per capita demand. And quality of water, and pressure in the distribution system, that also plays a role. And sewerage facilities, I already mentioned to you, have a combined sewer or separate sewer system. And the system of supply, where you may have a continuous and also intermittent. Probably would have come across two different supply systems in your city. Continuous water supply systems, you may get 24/7 water supply throughout. Okay, or they may have an intermittent water supply. So based on that, per capita demand also will vary. And the cost of water, now it is about policy. You have to pay whatever you consume. That's the cost of water, and the policy of metering and method of charges. Maybe monthly, or once in a year, or twice in a year, and based on that, this capita demand also will vary. Okay, yes. And variations in the demand, that's also I told you, because the demand may not be uniform throughout. Demand may not be uniform throughout your system. Morning you may have a maximum consumption, and say example from 10 o'clock to 2 o'clock in the afternoon or mid period, you have a lower in consumption, and even again the consumption starts after 3 o'clock. It will go up to 6:30 or 7 o'clock or 8 o'clock, depending upon your city conditions. it will also have a variations in demand. Okay, so that we'll be discussing a graphical pattern of demand variations. Okay, yes. Third lecture, population. That's I told you. Population forecasting is something is an important factor in developments of water-related or water distribution network projects. Okay, so probably you would have come across IDM population growth curve. Okay, logistic curve. Okay, population growth may have a trend. Okay, we will be discussing in detail. And these are the different forecasting methods. Okay, that you may have arithmetic increase method and geometrical increase method, incremental increase method, and graphical interpolation and comparative graphical method. And they may have a master plan method of estimation. And last one is about logistic curve method. So these are the 5 different methods, and each and every method may have advantages and also drawbacks. Advantages in the sense is it will calculate the actual value. The drawback is it will also project excess. Say example, the population of like 2011 in Trichy maybe of 10 lakh. Okay, and if you follow any methods, and it will project in say example 21 or 31 in accurate value, it is no problem. If it is projection by 10% excess or 20% excess, obviously it will also increase the project cost. Okay, so that we'll be discussing in detail. Different population forecasting methods. Okay, yeah. So being familiar with population forecasting, and then we'll move on to sources of water. That's what I told you. Sources, you can classify surface sources and subsurface sources. Surface sources mainly ponds and lakes, streams and rivers, reservoirs, and ocean. Okay, sea. And typically, it is not being used extensively for water supply. Nowadays, people have targeted saline water or seawater tapping also for domestic consumption. You would have seen. Okay, Chennai is the best example. They have 2 desalination plants. Those who are familiar in developed nations like or Arabian countries, they may normally depend on sea or ocean for groundwater supply or water supply. Okay, when either sea water or other sources. Okay, so we'll be discussing surface water sources and subsurface, and those who are from nearby, say example mountains, or those who are nearby food plains, they would also experience these sort of subsurface sources: spring, infiltration galleries, infiltration well, and tube wells. That is very common in rural areas. So you may depend with subsurface sources. We'll be discussing in detail with the estimation, quantity estimation, or the yield of individual subsurface sources. Okay, and hydrological cycle you would have come across in school levels or in the first year. And what are the different types of precipitation? Okay, and you would have also noticed in televisions you may have different precipitation behavior in Tamil Nadu right now. That is because of cyclonic or orographic or conventional precipitations. Very common, they used to say. Okay, these type of precipitations we'll be discussing in detail, and how to tap the water from these sources. Okay, normally it is all classified as intake structures. Okay, either intake towers, or they may call it as submerged intakes. If you are depending with canal intakes, river intake, lake intake, and reservoir intakes. So that we'll be discussing mostly surface and subsurface sources. Okay, yes. Now sources has been identified. Now we have to convey the water. Okay, convey the water with 2 different conveyance methods. One is free flow system, another is about pressure flow system. The free flow systems are what I meant for is gravity flow. You need not depend on anything with pumping. Pressure systems is obviously with pumping system or pumping methods. Elevations may not permit, and either way you have to pump the water from the source to the treatment plant, from the treatment plant again to a consumers. Okay, so we'll be discussing different conveyance method and how to select the pipe material for different conveyance. That also we'll be discussing. These are different types of pipes: cast iron and galvanized iron, steel pipes, cement concrete pipes, pre-stressed concrete pipes, reinforced concrete pipes, Then asbestos cement pipes and PVC. Okay, that we'll be discussing in different types and material clusters and advantages and also drawbacks, and how to lay and how to connect and how to test the water supply networks before implementation. That's we'll be discussing in detail. And each and every pipe networks may have a different joints. Okay, that you would have seen in your household level also. Okay, so they have, these are the classifications: port joints, spicot and socket joints, and there could be a flange connections, flange joints, mechanical joints, and joints which is especially for concrete and asbestos cement pipes, screwed and socketed joints, and special joints. So we'll discuss, and you can also observe what is going on in your city while you are moving out, or you can also see some like pipe fittings and also features in your household level as well. These are the pipe fittings probably would have come across: the elbows, tees, union, pushing, reducer, coupling, and cap and plug and nipples. And these are the pipe appurtenances. Okay, predominantly valves. Okay, sluice valves and check valves, angle valves, and ball valves, flush valves, and air valves, and other different appurtenances that also we'll be discussing in detail. And what are the different types of pumps and pump essential components in the pumping station. Okay, probably you would have come across bigger pumping stations in your cities as well. Okay, classification of pumps. Mainly they may use hydraulic pumps, centrifugal pumps, axial flow pumps, mixer flow pumps or otherwise jet pumps, and positive displacement or reciprocating pumps, screw pumps. So these are the different classification of pumps and pumps used in the pumping station. Okay, yeah. So now once we are familiar with the pumping operation, now understood that water you have brought from reservoir to a city. Now we have to plan for a treatment. Okay, so these are the different treatment, and before going into a treatment option or process, we'll be discussing a lot of layout diagrams for better understanding how to choose or how to pick up and how to arrange a treatment chain. So that we'll be discussing in the sense of surface water and groundwater. So let me expose like all of you to surface water treatment chain and groundwater treatment chain with layout diagrams. Okay. So once the layout diagrams are fixed and you have a basic knowledge of how to mix or how to pick up the different treatment options, and we'll move on individually with different treatment options. Okay. The first method is about first treatment option is mixing. Okay, mixing is you have to add the coagulants, and you have to mix the coagulants thoroughly with the water, or you have to disperse the chemicals, whatever you use it for the removal of hardness, except say example lime and soda ash. Okay, and for the removal of colloidal matter, you may also add coagulants. How to disperse the chemicals into the water by typical mixing mechanisms. So that we will be discussing in detail. The first process, mixing, different types of mixtures in water treatment system. And coagulants, that I told you, the water, whatever you tap from surface water sources, predominantly contaminated or mixed with a lot of micro or colloidal materials, which may not able to settle down by proper sedimentation or settling mechanism. So, and also these particles are negatively charged. Because of this negative charges, it will repel each other. Okay. So what do? You now add coagulants, thereby you reduce the repulsive force and make them to be, or you just have a particles to collide each other. Because of this collision, the size of the particles will become bigger. That can be subsequently removed in the sedimentation or settling process. Okay. So these are the different coagulants has been added in water: alum, ferric chloride, ferric sulfate, and chlorinated copras, and aluminate, sodium aluminate. And how to determine the dose, optimum coagulant dose based on your water quality, and they have the determination that also we will discuss in detail. And after coagulation, then next process about flocculation, probably during the course of time you can also understand better. Flocculation is the process where you can make the particle to collide each other by simple gentle mechanism. So coagulation is addition of chemical, and flocculation is destabilized flocks are brought together by simple agitation or mixing mechanism. So that's classification are micro and macro flocculation, and different types of mixings used in flocculator we'll be discussing. Okay, so now the flocks are bigger because of this flocculation activity, and during settling you could able to settle very easily. Okay, sedimentation or settling tank. So here we'll be discussing what is sedimentation theory, what are the different types of settling behavior. Okay, number one, discrete particle settling, flocculent, hindered, and compression settling, and different zones in sedimentation tank, how to design a sedimentation basin, and different types of sedimentation tanks as well, horizontal flow, radial flow, vertical flow, and you can combine together with sedimentation and flocculation together. That is called clariflocculator. Okay, yes. And the next process is filtration. That's I told you, because whatever the flocks which is already being formed in the flocculators are not uniform in size. Some particles are bigger and some particles are very tiny. That's what I told you, like the micro flocculation and macro flocculation. Macro are, say example, particles are bigger, and thereby it is easy to separate in the sedimentation or settling basin. And particles are very tiny. So flock particles are very tiny. There is no point to keep the particle in the sedimentation tank for larger period of time. Okay, that normally adds detention time will be very higher, or otherwise I have to design for a sedimentation tank in a bigger size. Both of them may have negative impacts. So what you do, I have a simple system called filtration. Okay, so you just arrange different layers of sand particles or other polymeric materials or polymers. Okay, arrange layer by layer, then just allow the water to pass in, and because of screening mechanism, okay, top layer of the sand will act as a micro strains which will retain all the flocks, and after filtration, and there could be a possibility of water which is free from these micro flocks. Okay, anyway, this will be discussing physical classification, hydraulic classification of filters, and based on rate of filtration you can also classify into slow sand filters and rapid sand filter, and mode of application you can have a depth filtration and cake filtration, and what are the different transport mechanisms that we'll be discussing, filter components, and how to estimate the head loss, and how to operate the filter, that we'll be discussing in detail. Okay, and the last part is about disinfection. All the treatment systems what we discussed prior will not attempt to remove your microbial population. That something is important. That's what people used to say, tap a water from a source, and have a treatment in your household level or point of use technologies, and after POU also just have a simple boiling. Okay, make sure that there is no contaminants in the pathogens or microbial contaminants in the water. Okay, so these are the different types of disinfection by physical methods or by chemical methods. Physical methods are simply with boiling, and you can also add excess of lime, and treatment with ozone, and treatment with iodine and bromine. And nowadays a very recent concept has come, you can also purge UV rays, UV disinfection, and very latest they may also use silver electrodes to kill pathogenic microorganisms. Okay, yes, and we'll also discuss what is chlorine chemistry and what are the different types of chlorination. Okay, you can do the chlorination prior your treatment option, that is called pre-chlorination. After the treatment process, that is post-chlorination. If you do prior and post, that is called double chlorination. And if you use excess chlorine to take care of your future contamination, that is called superchlorination. And if you use superchlorination, then you have to remove the chlorine at the usage point. That you can call it as dechlorination methods. Okay, so this covers entire surface water treatment layout or treatment chain. Okay, and in the case of groundwater, then you have to be cautious with iron and manganese. Okay, how to remove iron and manganese from the water, that what you have to, how to remove iron and how to remove manganese from the water, that is simple by simple aeration methods. That's you would have seen. I think those who are familiar in groundwater sources or groundwater treatment plants, you would have also seen water fountains. That are not water fountains, that is our aeration mechanisms. You just take a water and splash it through some sort of in a cascade aerators, or you expose to atmospheric oxygen, thereby whatever it is present in groundwater like iron Fe2 plus and Mn2 plus will be converted into Fe3 plus as well as MnO2. Okay, MnO2, manganese oxide as well as your Fe3 plus. Thereby you could able to separate in a settling tanks. That we'll be discussing in detail. And how to soften the water. Probably in groundwater, major problem is about hardness. So how to soften the water, then we may discuss something on lime soda process, caustic soda, and how to stabilize the water. That also we'll be discussing lecture 14. And how to distribute the water after treatment, then probably you would have come across some areas or some cities may follow a gravity system. In some cases, they may also follow a pumping system. And some cases, they may also follow a dual system, combination of gravity and pumping. Okay, that we will discuss. And layouts, probably you would have come across. Those who are in well-defined layouts, you would have also experienced these sort of distribution systems: dead end system, a gridiron system, a ring system, and radial system. And these, they may have advantages and also drawbacks. That also we will discuss in detail. And how to analyze complex pipe networks, that also we will discuss. Okay, by simple Hardy-Cross method. Okay, that will solve a simple networks, how to optimize the diameter and how to optimize your pressure in a networks. That also we will discuss. Okay, and the last part is about the time permits. We will also discuss advanced treatment systems. Probably you would have come across the names. Membrane filters. Probably each and every household, they may have either ultra or micro or nano filter, or they may use reverse osmosis. Those who are nearby seashore areas or those who are nearby groundwater sources, they may use reverse osmosis point of use plants in the household level. Or those who are near in river water courses, they may use either micro, ultra or nano filtration techniques to treat the water. Okay, yes. And how to remove the dissolved organic constituencies, you have adsorption. That anyway, that we'll be discussing in detail. Carbon adsorption or chemical oxidation or chemical precipitation methods. And biological constituents, again, membrane filtration and exchange, some cases with adsorption also. Okay, and these are the last prayer lecture is about how to supply the water in the buildings. That is something is important. Okay, we'll be discussing in detail plumbing details or plumbing methods in the buildings as well as houses. So that we'll discuss in and how to store the water in your boundary. Say example in your household boundary, and probably they may use underground storage or they may use overhead storage. And how to distribute the water in the multi-story building also. So that also we'll be discussing direct pumping system or hydro-pneumatic system and overhead tank system. So this will discuss distribution systems in the buildings. So last portion is rural water supply system. Okay, so that is this whatever we discussed so far is urban water supply systems. There they afford to have water treatment plants, but in the rural it is not like that. Okay, so we'll be discussing now some details on how to collect the rainwater and how to recharge the groundwater by simple recharge methods, and how to extract the water from a well, and what are the commonly used hand pumps in the rural water supply system, and how to take the water from the ponds. Okay, and in the rural water supply systems, we are not in a position to give sophisticated or advanced treatment technologies. So you have to plan for very small and usable and viable technologies for a rural level. So that normally they may follow a slow sand filtration or predominantly alternative filtration technologies. Okay, and how to remove fluoride as well as iron in the household. That also we'll discuss in detail. And the last part is about salt water intrusion. Okay, that also it has been given importance, because excess tapping of water near the seashore areas, there could be a possibilities of migration of seawater into a land courses, seawater into a land, which will cause a lot of problems. Okay, so we'll discuss in detail with causes, problems, and what are the factors affecting the saltwater intrusion and how to control or how to prevent the saltwater intrusion. Okay, so this covers the entire subjects, and this is my process flow or concept map flow, and my lectures are based on this sequence. Okay, this also I'll post it in the Dropbox. Have a look, and you can also have your segmented way of learning, and based on the updated or uploaded course materials. Is it okay? Is it fine?
Yes, sir.
Yeah. So I guess I've given some enough introductions about the content, what I'm going to cover. Okay. So you need not worry about much with your course coverage or content, and whatever I discuss, whatever I solve, and I'll also post in the Dropbox. Okay. So my my lectures will be available in Dropbox, either in a like text format or in a lecture format also. Okay, so probably I'll try to post these recorded lectures also in the Dropbox. And some people, they may have habit either to hear or either to see your handwritten or PDF documents. So based on that, you just develop some sort of interest to learn the subjects. Is it okay? It's fine.
Yes, sir.
Yeah. So Rashwant, can you make the attendance, because is anyway I'll download my attendance in the Dropbox when this MS Team. Kindly also make like who are all absent in the class, and after the class you just immediately text me the roll numbers, last 2 digits of the roll number, then I'll mark it in the attendance book. Is it okay?
Okay.
Okay, Rashwant. Divya also kindly follow up. Okay. So, yeah. Any interactions? And I may not know.
Can you suggest some books?
Yeah, that I told. No? Then once it is ready, Dropbox is ready, and my course plan is ready, I'll upload enough number of books. You need not worry about. Maybe today or tomorrow. Tomorrow I may have some free time. I'll upload tomorrow all the essential books. Is it okay? Yeah. Ranjan, it is fine?
Yes, sir. Yes, sir.
Okay. Yeah. Thank you so much. Yeah. Yeah. So, Rashwant, immediately after the class, you just post it. Okay. Attendance.
Yeah, okay, sir.
Okay. Okay. Thank you so much. Yeah. Bye.